Hi, everybody, and welcome to another amazing episode of the Infrastructure as Code podcast. My name is Ohad Meislich, and I'm the host for today. You can follow me at DevOps Ohad in Twitter. And today we have, wow, an amazing guest that really changed the history of infrastructure as code or cloud with code, Adam Jacob. Nice meeting you, Adam. Hi.
Nice meeting you too.
Can
What a
you
nice
tell us
thing
a
to
little?
say.
Thank you. What what
Yeah.
what a nice thing to do, creating creating Chef. So
Yeah.
let's talk about your role in the history of moving cloud from ClickOps to code.
Yeah. Yeah. I mean, I created Chef um, out of a consulting company that I was running with that I had with some friends, and then
Mhm.
that became Chef. And yeah, we were sort of present at the creation of a lot of the sort of modern DevOps movement. And then before that, I was a big CF Engine and Puppet user. Yeah, my most of my professional career has been building in that space.
So let's talk more about that. Why you created Chef?
Well, I mean, there were a couple of practical reasons. So this was back in 2007, right? 2006, 2007. We ran a consulting company that built fully automated infrastructure for startups. So basically, you paid us a flat fee, and then we would go build we would automate all your infrastructure as quickly as we could. And how we made a big profit on that work was that we were super fast at automating everything. So it was, operating system installation, monitoring and trending, application deployment, everything, all the things, identity management, all that stuff. And the fastest we could turn one around was like 24 hours. So we were really good at fully automating people's infrastructures. And we were using Puppet to do it at the time. And there were just a couple of things that were sort of in the way. So we were one of the folks who were really early. We weren't the only ones, but we were early to thinking about trying to automate everything. So thinking about every single system, every single package, every single thing you do being automated. And the tools just didn't work very well as the complexity increased. So, Puppet was at the time was great on many levels, but once you started to have, hundreds or thousands of discrete pieces of configuration you wanted to manage, we started to run into issues around how Puppet sort of thought about order. So it would occasionally do things out of order that would then cause bugs, which then, there were always ways to work around, but it was sort of a pain. And so Chef was really born from us selling automated infrastructure to customers and then winding up in a situation where, one time out of 30, the Puppet run would fail and we wouldn't know why. And so the two things that really brought us to Chef was, how do we solve that problem of thinking through how do we express what we want and make sure that it happens the same way every time? How do we make sure that it's fast enough and scalable enough to sort of live in that cloud, in that what was an emerging then sort of world of cloud computing? Um, and and how do you think about scaling that system in the large? So if you were going to use this infrastructure automation to run the largest infrastructures in the world, so like Facebook, for example, wound up rebuilding all of their infrastructure on top of Chef, still to this day, I believe, using Chef to do all that stuff in their data centers. How do you build a configuration management system that scales to that level? And those were sort of the challenges for us.
Awesome. So I think you've mentioned 2007 when you started doing that.
Yeah.
Public clouds were just in the early days,
Yeah. EC2 and
and
S3, basically.
yeah, so though EC2, virtual machines, S3, storage, not too many types of cloud resources, but later on, AWS and then Azure and GCP evolved, and the need for a dynamic infrastructure, I believe, evolved over time. How do
Yeah.
you look backwards and see the role of Chef and maybe other configuration management frameworks versus infrastructure as code, maybe such as Terraform that was created to focus on the infrastructure? What are your thoughts about this change?
Yeah. I mean, the configuration management world was structured around more generic compute, right? So
Yep.
as when the challenge was, how do I make generic compute specific? The answer was configuration management, and we were great at it. And Chef in particular was great at very complicated infrastructures with really big, complex requirements. As the cloud evolved, more and more of what would have been configuration management complexity, right? How do I deploy this highly available application or databases across generic compute and arbitrary data centers with, arbitrary network designs, all of those sorts of things, started to become things that happen behind API calls in cloud providers, right? It was like, oh, if I want a highly available Postgres instance, I don't need a bunch of configuration management to do that. I can just make a call to RDS, right? And now what I have is a client. And I think you can look broadly at the evolution of Terraform and of Pulumi as roughly Puppet and Chef in terms of the varying approaches to the concept. One of the things Chef kind of pioneered was the idea that your configuration management should be written as an internal DSL to a programming language. That I didn't want an external DSL that constrained me. I wanted a full programming language to solve my problem. Pulumi, absolutely in that same camp, right? Like you should be using a programming language to solve this problem because what you're doing is programming. And you can look at Terraform and Puppet, and they've both sort of evolved into general purpose programming languages, right? HCL has loops now and functions, and you can do all kinds of crazy shit that you couldn't do in the beginning. But that evolution was basically a natural extension of the fact that the configuration management problem had evolved beyond how do I configure generic compute nodes to how do I assemble all of these various API pieces together to make it work. And then they had their own problems, which were that now you had the idea of state starts to creep in, where state management for configuration management was easy because you would just look at the compute node you were on and make decisions. In the cloud, it was harder because the gathering all of that data, how do you store it? When does it update? How do you know what the drift is? Became a different layer of problems. So I think, Terraform and Pulumi both are evolutions of that same configuration management trend, just pointed at the idea that most of what we're configuring at this point are APIs.
Definitely. So now let's say the DevOps engineers, they need to manage their applications and infrastructure in the cloud, and maybe they're using both infrastructures, code such as Terraform, Pulumi, or let's say CDK. If you mentioned the Chef approach, I would also add CDK to the conversation, maybe. So they need to do both, but maybe they look at it from the technical perspective that they need to implement and write this code. And correct me if I'm wrong, but this is maybe the reason why you started the system initiative, to look at that from the use case and the day of life of the
Yeah,
DevOps engineer. Is that the right thing to say?
that's totally fair. I think for me, my experience watching us sort of go and take DevOps into the world was that we had all these fantastic tools like Pulumi, like Terraform, like the CDK, incredible CI/CD platforms, Docker, Kubernetes. All this stuff has evolved over the years to solve different pieces of the puzzle in terms of how we're going to put the stack together, or how we're going to manage our infrastructure, or how we're going to handle these complex deployments, especially when we think about what's that boundary between application developers and operations people. I think
What is this boundary? Can you talk more about it?
well, so ideally, it's a very porous boundary. So, what we know about outcomes in DevOps are that when teams collaborate together closely, the results are amazing. And the more stuff we put in between, the collaboration between software developers and operations people, the worse the outcomes get. This is why, if you look at the DORA report, most people are stuck in the middle, right? Most people who are doing DevOps, they're like, yep, we deploy sometime between every month, every week, and every month. Our failure rate is, in the 16% to 60% range. Those are not great outcomes if you think
No,
about our
no.
aspirations for DevOps, right? They are great outcomes if you remember what it was like in 2006. But, it's not like if you read the DevOps handbook, it's not what it tells you want. We're like, hey, we want the safe deploy of software into production tens, hundreds, or thousands of times a day through a collaborative process with all these different people. That collaborative process, by and large, hasn't emerged. Instead, what's emerged is a series of tools, all of which are fabulous on their own, that when you string them together, create a workflow that sucks. Like actually doing DevOps work, actually sitting down and saying, hey, where do we put this Terraform code? How does it get into this pipeline? How does that dovetail with the application deployment architecture? How do we communicate? Like our best answers to that is essentially this constant retreading of building portals. We're like, hey, you know what we'll do? We'll just like try to box it up. You can have any color you want as long as it's black. And as soon as you have to like get into the details of what's really happening, it's like the stars have opened up unto you. Do you know what I mean? And you just need to eat the whole complexity of everything, including, learning how to do the infrastructure as code layer and how do we program it and how do I understand how that relates to the actual cloud resources and how are they different and when can I make changes and where can I make changes? And that experience is, let's just call it bad. Like from a pure user experience perspective, it's kind of awful. And I felt that way toward the end of my time at Chef, that like we had gotten to a spot where I could tell people how to do it. And if they did what I said, then it would work. And also no one could actually execute it the way that it needed to be because it was just too fragile. Like you would make different choices or small decisions about the shape of a pipeline or small decisions about the decision about how people will work together had huge ramifications for your eventual success. And I just came to believe and do believe now that that's because we just fundamentally didn't design the system around collaboration. We didn't say, well, how would we build a system that allows people to collaborate together to solve these problems? What would a system like that look like even? And then build from there. And so that's what I've been spending the last 4 years doing at System Initiative, is running a series of experiments into if you wanted to build a system that provided an order of magnitude better return on the results of people collaborating together on these DevOps problems, what would that be?
And so basically, you have a company, you have a product called the System Initiative. I also saw that you have your own open source. Can you tell us a bit more about your commercial product and the open source and zoom into
Yeah,
that?
so it's all the software is open source. So every line of code that is in System Initiative is open source. Our commercial model is really straightforward. We open source all the software that builds System Initiative, and then System Initiative itself is a commercial product that we sell. So anyone can take the software and you can do whatever you'd like with it. What you can't do is call it System Initiative. Yeah. So if you took it and you wanted to make like OHAD's version, you could totally do that. You could call it OHAD. That'd be great. We can collaborate in the upstream. But what we make and produce is System Initiative, and we sell it for money. So it's roughly the same model as Red Hat. And yeah, that's because we really believe that if what you're doing is trying to transform the way people work, then you can't put limitations on how people find value in that transformation. So if you find value in that transformation by taking System Initiative and running it yourself, or even distributing it yourself or competing with me, great. I want you to do that, because what I want is that technology to go into the world and be transformative in your life.
Awesome. So let's talk more about this approach. So from your perspective, the DevOps engineers need to have like a centralized place in which they declare their decisions, and later those decisions generate code that does the needed things, right? Whether it's
Yeah.
calling the APIs of the cloud vendor and provisioning and
Yeah.
updating the infrastructure.
I think if you take a step even further into the like nerdy vortex of how it works, there's sort of 4 things that are wrong in the current approach. So, but really you can focus in on a few. So one is that there's the collaboration and the feedback loops are quite bad. So if you look at how long it takes to know if what you've said is right or wrong. So you're writing some Terraform code. How long before you know if that Terraform code results in a working infrastructure that runs your application? And the answer is hard to say, right? The bigger it gets, the longer it'll take, right? So to know for sure, you have to go build all the infrastructure already. But even to know in theory, like how do you know what you've configured? How do you know if it would work? How do you know if it meets the corporate policies that are in place? Like, there's a huge problem of just how do we know if what we think we want is even going to work at all? And then there's the feedback loops of once it's running, how's that working? Has it been changed outside of your purview? Do you understand what needs to happen next? All the day two stuff, all those things are really quite poor feedback loops. That question of feedback loops led us to say, well, if we want to fix those feedback loops, one of the things you have to do is you can't just call the cloud provider directly because it's too slow. So we started building a simulation that said, what if we built this high fidelity model of how all this infrastructure in the cloud functions? And then what you interacted with was this high fidelity model, the simulation of the real thing. And then we could start putting policy inside that simulation. So we built this big simulator in the same way that, like, if you watch Formula One, the cars go around the track every weekend, but they have big simulators back at the base where they're simulating every facet of that car. They're building a digital twin of the car, and they use that simulator to decide what the setup should be for the car before they run the race. So the system initiative basically works the same way. We're a system for building this big simulator of your actual architecture. And the way that works under the hood is it's a big hypergraph. It's a big multidimensional graph where each configuration value is itself the result of a function. So you can imagine and it's reactive to its inputs. So you write code that reacts to its inputs to set values. And that's where we can start getting intelligence. So you can say things like, hey, my application lives in this Docker container. It exposes itself on port 80. It has a relationship to a CoreOS image and a relationship to a load balancer and a relationship to a security group. And through those relationships, we can infer that what you want is the security group to open port 80. You want that Docker container to run on CoreOS and expose itself. You want a load balancer that creates a load balancer pool for all the instances that are running that application. And all that's inferable automatically by this graph. You express that stuff visually. So we allow you to basically draw a diagram that describes those relationships. And we can give you immediate feedback loop on that diagram. So we can say, without actually doing anything, hey, this Docker image looks like it would work, or I can't find it. It's not real. You have a typo, right? Or it doesn't make sense to configure this load balancer this way. And you can start to apply corporate policy that way. And the side effect is that when we give you these interfaces, we can make them multiplayer. So we can make it work more like Notion or Figma or Google Docs and less like Terraform in your own editor alone. And what it does is then make it easier and safer and faster for people to actually do this work together.
Got it. So just to make sure I fully understand, you add your own, basically, thanks to the digital twin, you are capable of ensuring that whatever the DevOps engineer designed will work and make sense and is according to the needed policies. Is that the right thing to say?
Yeah, totally. You can also use that same digital twin to go the other way, right? So we've separated out in tools like Terraform or Pulumi, there's a state that gets tracked where the code is the source of truth. So we say that the source of truth is the code we write, and then the cloud provider is going to get manipulated to match that source of truth.
Correct.
In System Initiative, we break that apart and we say that they're actually both true at the same time. There's the truth of what's actually been deployed in the resources. That's a thing we're tracking separately all the time. Then there's the truth of what you say you want hypothetically. And that's also true in that hypothetical instance that we're talking about. And what a human being does is decide, how do I reconcile the two? Like, if there's a delta, what do I do? And so by thinking about the flow that way, what it enables is a much easier way to think about collaborating in all sorts of different circumstances. So a good example would be if there's a production outage and you know how to fix it in the AWS console, you can just go fix it in the AWS console and have System Initiative update the model backwards, as opposed to in Terraform land, where you would need to go figure out, like, well, how do I change this in Terraform? And then how do I run that thing? And how does that make sure it happens? Or I do go fix it in the console, but I have to make sure no one runs Terraform until we get the right update right. And it's all very high wire acty, right?
Got it. Got it. So just to basically summarize, this approach is a centralized system that allows you to declare of your provisioned infrastructure and have all of those add-ons thanks to the insights and the digital twin and all of the capabilities within system initiative. So basically, my question to you, because this approach is very novel and promising, but it's a different approach than asking engineers write your Terraform code and then add your policies in Open Policy Agent and make sure
Totally.
you don't have any security vulnerability if you use something like Chekhov. And do everything with GitOps and test everything in the pull request. And
Yeah.
by the way,
Yeah. Couldn't be
you
more
need to
different.
by the way, you need to handle drifts because those can
Totally.
occur all the time. So those are two different approaches. From your obviously vast experience, what do you project that will happen in cloud management and the day of a DevOps engineer 5 years from now, 10 years
Yeah.
from now? How do you envision infrastructure as code? Maybe with the combination of configuration management frameworks such as Chef
Yeah.
versus a centralized platform such as System Initiative.
I mean, I think of it this way. I think what we need right now is a recognition that the status quo isn't serving us as well as we wish that it would. Which doesn't mean that it's not working. It is, or that we shouldn't be proud of what we've built. We should be, but it could be better, and we know it. Like in our hearts, we know it's not as good as we wish it could be. Like it's like you just described a whole lot of tools to stitch together. That like it's pretty great when they're all together, and also getting them all together is a real lift. And then once they're all together, like managing that is also a pain. And like I think what we need right now is the recognition inside the DevOps movement that we need like a second wave of DevOps tooling, that we need people, not just me, but all sorts of folks who have good ideas about how we could do things differently to try it. We just need people to try doing things in different ways and to actually innovate again in the same way that we did when we made Chef, in the same way that Mitchell did when he made Terraform. Um, and and we need to do that again. And we need to really think differently about what's possible. So when I think about 5 years from now, I think if we're successful in getting people to really push hard on that innovation loop and say, hey, let's try lots of different approaches, like not just system initiatives approach, like maybe the Q guys are right. And it's actually just a huge configuration problem, literally a configuration language problem. And that if we just could be more expressive in the way that we put together large scale configuration and then manipulate it, then the results would be better. Maybe they're right. Maybe the wing guys are right. And what we need to be doing is writing annotations inside of a custom made programming language for the cloud. And that then generates the infrastructure as code. Maybe they're right. Maybe system initiatives right. And the way forward here is to basically build a giant simulator and model everything that way. My belief in 5 years, obviously, is I think system initiatives right. Um, but I don't have so much hubris as to just like declare that like my way is the future. Like we all have work to do. And I think the number one thing we need to do as an industry, and that I'd like to see different in the next 5 years, is I'd like to see how that workflow works for the people who do DevOps, make their day-to-day life an order of magnitude more pleasant. Like, can we just make it so that doing that work sucks a lot less 5 years from now, because what it's doing is allowing us to work better together, bringing us closer to each other, allowing us to produce better results, especially in those really large enterprises where I think it's not uncommon to get really bogged down in the shape of those processes.
Awesome. And interesting that you mentioned Wing. The creator of Wing was a guest on a previous episode of this podcast. And he's, by the way, also the creator of CDK that we mentioned earlier
Yeah, totally.
in the
Exactly. And
conversation.
like, yep. And I I I have I have a theory. My belief is that Wing probably isn't the right direction as for us to go as an industry. But like, what the fuck do I know? Yeah. Like in the end, it's it's gonna happen because we're gonna go. Like, I want to see it happen. Do you know what I mean? Even though I think that that's true, I'm still cheering for Wing, because what I'm cheering for is the actual, I want the change to happen, right? What I want to see is that change in those people's lives, so that that improvement happens, so that the people that I've worked so long with and that are my favorite, like I love DevOps work. I've always loved it.
Mhm.
And I want that to be better. And if it gets better because of Wing, great. Um, you know, yeah.
Awesome, awesome. And small disclaimer: I'm a tiny small investor in Wing Cloud, so I hope
Well, it's all good. We could still be friends.
we can
Like,
still definitely be friends.
because I think
Uh,
it's interesting. It's so cool, right? How do you not want to? How do you not want to know more about how those things
Awesome,
are, what can work, and how it's possible?
definitely. One last question, Adam. Back to Chef.
Yeah.
Uh, can you name one thing you're proud and like a decision that you're happy that you made a long time ago regarding Chef, and also one decision that looking backward, you would have done differently when it comes to Chef?
Oh. Um. Well, the number one thing that I'm proudest of, and would do again, and am doing again with System Initiative, is the way that the chef community was built, and the way that people learn to support one another and to take care of each other in that large community in a time of real transition. You know, if you think about what happened in corporate life from 2008 to 2010, um, or 2015, sorry, not 2010. It was a big transition, and I think the chef community did a lot of great work helping each other understand how to navigate that transition, and how to improve themselves, and how to improve their careers, and how to care for each other. And that's still a community to this day that I think has a lot of care for each other, and for the experience of doing that work. And I'm so proud of that community, that it existed at all, and sort of how what it the impact it had, I think, on people. If I had a thing I could have changed, um, we learned a lot about open source and business, and about thinking about how the tension between open source and the community, and the need for a business to make money, influenced each other. And I think it took us a really long time at Chef to come to the conclusion that the core problem in our business model was that everything we did wasn't open source, and that the monetization of the product was actually the sort of key mistake. That if you look at the tension between the community and the business, I think we could have done a better job sooner of aligning our business success to the community's success exclusively. And I think we failed to do that early, in ways that both harmed the business and harmed the community, as we grew. And I think there was, in hindsight, there were good answers to those problems that we just didn't understand. And so I would have made that transition to a business model that looks more like Red Hat's, much sooner, or at the very beginning.
Super interesting, and thank you for your humble and honest thoughts being shared here with everybody. I think that summarizes the conversation we had today, Adam. I really want to thank you for sharing your insights and your vast experience in code, in DevOps, together with our audience today. So thank you
Oh,
so
thanks for
much,
having me.
Adam, for joining. And that's it for today. Thank you everybody for joining the episode. I'm Ohad Maislish. Please go to the DevOps, the IaC Podcast.com. Follow in Twitter and LinkedIn. And if you like the episode, share with your friends. Have a great day, everybody, and take care. Bye bye.
Thank you.